Welcome back. Today we're continuing on with chapter 9.4, which is subtraction. First, we're going to start off with a definition of subtraction. Now, we don't usually have nice definitions. The wordage is a little funky for mathematicians, and they have to be very specific because our order in which we state things matters to us. So what we're going to do is read this definition. It says the difference, a minus b, is the unique number c for which a equals b plus c. And what we're going to do is pretty much try to translate that into English. So how we're going to do that is with an example. We're going to start off with a really basic subtraction problem, 6 minus 2, which you might know the answer for, so hold on. What we're going to do is think about it in the way that the definition is stated. So, reading it again, the difference a minus b is the unique number c for which b plus c gives us back a. So what we're going to look at is our b. We have 2. And we got to ask ourselves, what plus 2 will get us a, which is 6. And 2 plus 4 is, in fact, 6. So that's how we got the answer. Now, this you probably have already been trained since elementary school that 6 minus 2 is 4. It gets a little bit funkier when our examples are not as straight to the point. Maybe we have something like 6 minus negative 2. Now, we still have our b here, which is now negative 2 instead of positive 2, because it's minus, then minus, right? So we need to figure out what plus negative 2 gets us 6, and we're not too sure. Now, if we say 4, we have negative 2 plus 4, which we did in chapter 9.4, and we said, okay, if the signs are different, you subtract. 4 minus 2 is 2, which is not 6, so that's no good. Bad choice. Alright, we got to start a little bit bigger, maybe negative 2 plus 8. So the signs are different. If we subtract them, we have 8 minus 2, which, voila, is 6. So 6 minus negative 2 is 8. That is a terrible way to think of it. And you're probably going, I'm going to shut this off. That is not how I learned it. And you're right. So before I go into the way that you're more comfortable with, I want to make sure we go over something. It's stated in 9.3, but I feel it's better placed here, called the opposite and additive inverse. So, what the opposite and additive inverse, their fancy definition, is saying we have the sum of two integers whose result is 0. Are called opposites or additive inverses. And there's probably a much better definition, so to speak, in your book or Google or anywhere really that someone can actually speak English unlike me. So let me give you an example. Let's say we have 2 and we want to add to it something that will get us a result of 0. And you probably already guessed it, negative 2. 2 plus negative 2 is 0, right? 2 minus 2 is 0. So there is the two opposites of each other. 2 has opposite negative 2. And we could say the reverse. We could say negative 2 has the opposite 2. Pretty much you just change the sign. So if it was positive, now it's negative. If it's negative, it becomes positive. And that's our opposite additive inverse. So let's go back now to our crazy problem where we had 6 minus negative 2. Instead of viewing this as a subtraction problem, we can view it as an addition problem. So we're going to go down to this box I have here, where instead of a minus b, we can view it as a plus the opposite of b. And a good way to remember it is you keep the first part. Instead of subtraction, you change to addition. And whatever you had originally, you're going to change it to the opposite, and that's what you're adding. So that's what we can do here. Instead of 6 minus negative 2, we can do 6, keep it, change to addition, And the opposite of 2 is positive 2. And 6 plus 2 is 8. And now if you don't believe me, you can go back to our first page in which we had 6 minus negative 2 and we did the crazy definition and we got 8 once more. So that's what we can do instead. This makes life much easier when numbers are much more difficult to work with. So that's what we're going to do. We're just going to do a couple examples where the directions say subtract. Our first one, we'll be nice to ourselves. Let's say we have 5 minus 8. Maybe you can figure out what 5 minus 8 is right off the bat. But if you ever are doubting yourself, you can always change it into addition. So you keep, you change, and you change. Instead of subtracting, you can add the opposite. So now we're adding two things with different signs. And what we learned in 9.3 is we take the absolute value of each one. Whoever is the bigger absolute value, we take it, subtract it by the smaller, and keep the sign of the bigger absolute value. So it was negative, so our answer should be negative 3. And it flows a little bit nicer. Or you could just count on your fingers, 5 minus 8, not sure how you do it, but have at it. It doesn't make a difference how you go about it. Let's see one where it's a little more useful for that keep, change, change rule. Let's say we have negative 7 minus negative 2. So we keep the first part. Even though it's negative 7, it's fine. We always keep whatever's in the front. Now instead of subtracting, we're going to change to addition. Instead of negative 2, we have the opposite. We change it to positive 2. And now we have negative 7 plus 2, which is a nice negative 5. And we can continue on. We could see it a little bit more different. Maybe we have negative 6 minus 4. And maybe it's not as clear to you exactly what's going on here, so you can use the keep the first part. You change from subtraction to addition, and you change whatever the number is into its opposite. And now you can easily see you have negative 6 plus negative 4, which are two negatives being added together, so we just add the two numbers and keep the sign. And that is pretty much it for subtraction.